In a room where chemistry is taught or practiced, a chart called the periodic table is almost certain to be found hanging on the wall. This chart shows all the known elements and gives a good deal of information about each. As our study of chemistry progresses, the usefulness of the periodic table will become more obvious. This section will simply introduce it to you. A simplified version of the periodic table is shown in figure 2.19. The letters in the boxes are the symbols for the elements. These abbreviations are based on the current element names or the original names. The number shown above each symbol is the atomic number for that element. For example, carbon has atomic number 6 and lead has atomic number 82. Most of the elements are metals. Metals have characteristic physical properties such as efficient conduction of heat and electricity, malleability, they can be handed into thin sheets, ductility, they can be pulled into wires, and often a lustrous appearance. Chemically, metals tend to lose electrons to form positive ions. For example, copper is a typical metal. It is lustrous, although it tarnishes readily. It is an excellent conductor of electricity. It is widely used in electrical wires, and it is readily formed into various shapes, such as pipes for water systems. Copper is also found in many salts, such as the beautiful blue copper sulfate, in which copper is present as Cu+2 ions. Copper is a member of the transition metals, the metals shown in the center of the periodic table. Relatively few nonmetals appear in the upper right corner of the table, to the right of the heavy line in figure 2.19, except hydrogen, a nonmetal that resides in the upper left corner. The nonmetals lack the physical properties that characterize the metals. Chemically, they tend to gain electrons in reactions with metals to form negative ions. Nonmetals often bond to each other by forming covalent bonds. For example, chlorine is a typical nonmetal. Under normal conditions, it exists as Cl2 molecules. It reacts with metals to form salts containing Cl negative ions, and it forms covalent bonds with nonmetals. The periodic table is arranged so that elements in the same vertical columns have similar chemical properties. For example, all of the alkali metals, members of group 1A, lithium, sodium, potassium, and rubidium, cesium, and francinium, are very active elements that readily form ions with a +1 charge when they react with nonmetals. The members of group 2A, beryllium, magnesium, calcium, strontium, barium, and radium, are called alkaline earth metals. They all form ions with a +2 charge when they react with nonmetals. The halogens, members of group 7A, fluorine, chlorine, bromine, iodine, and astatine, all form diatomic molecules. Fluorine, chlorine, bromine, and iodine all react with metals to form salts containing ions with a 1 negative charge. The members of group 8A, helium, neon, argon, krypton, xenon, and radon, are known as the noble gases. They all exist under normal conditions as monatomic gases and have very little chemical reactivity. Note from figure 2.19, the alternative sets of symbols are used to denote the groups that symbols 1A through 8A are the traditional designations, whereas the numbers 1 to 18 have been suggested recently. In this text, the 1A to 8A designations will be used. The horizontal rows of elements in this periodic table are called periods. Horizontal row 1 is called the first period. It contains H and He. Row 2 is called the second period, containing lithium through neon, and so on. We will learn much more about the periodic table as we continue with our study of chemistry. Meanwhile, when an element is introduced in this text, you should always note its position on the periodic table.